All right, here's a system, number 17D. And systems, there are two ways that we know how to solve these, okay? So substitution and elimination being those ways. This one is set up not so much easily for substitution, but a little, and not really easily for elimination, but I'm going to try to do elimination simply because it looks like that'd be the easiest route to go rather than try to solve for a variable and plug it back in. I don't want to work with fractions, so let's try to solve this one by elimination. So what that involves is multiplying one or both equations by a number in order to cancel out one of the two variables. So I'm going to try to cancel out the x's. And looking at the x's, I'm just going to do those because they're in the front. I could have just as easily try to cancel out the y's, but I'm going to try the x's. So looking at those, I can multiply the top equation by 2 and the bottom equation by 7. I don't always have to multiply by the opposite number, but it does get you numbers that are opposites of one another so that when I add the two equations, that the variables will cancel. So I'm going to distribute the 2 to every single term, and that's typically a problem where students sometimes forget to distribute it to everything. Maybe they miss the constant term out there, but you got to multiply everything by that 2 that is in front. So this is what I get. 14x minus 6y equals 12. And I'm going to do the same on the bottom. So 7 times everything. 7 times negative 2, negative 14x. 7 times 5, 35, and 7 times negative 10 is negative 17. What happens here is you should have two variables that are opposites of each other. If that doesn't happen, try again. But it should happen if you did it correctly. And by adding these equations straight down, I get negative 6 plus 35, which gives me 29. And I get 12 minus 70, which gives me negative 58. You should be able to get one of the variables right away. So it's divide 9 y equals negative 2. So I got one of my two variables, and at this point I was asking, am I done? Everybody says no, and the reason is because I need to find x, because the system has two solutions, x and y. So now you can come back to either of the equations. I can come back to the original ones. I can come back to the ones that I made, but I'm going to come back to this one just because it's closest, and plug in negative 2 for y and solve for x. And that is my last step in solving this system. So I get negative 2x minus 10 equals negative 10. I add 10. And then what happens here is I get 0. And a lot of times students say, no solution, whatever. No, but at this point, I still have an x, which means that it's not no solution. No solution happens when x goes away, when x cancels. X didn't cancel here. So I just divide, keep going, and just carry it out until the end, and you get x is 0. So my solution, my answer to this system is the point where x is 0 and y is negative 2. So hopefully that helps you solve a system by elimination.